So today what we're going to do is we're going to go finish up the notes on section 2. There's only a few examples left to work out. And then what I'm going to do is I'm going to go through and explain all 7 questions of your homework from last night. Tonight it's just more practice. It's 10 problems. It's a PDF again. Tomorrow I'll give you more practice. The more you do, the easier it's going to become. I know at the beginning you're like, where do I start? And again, I know it's trial and error, but again, use the tips. Whether it's changing everything to sines and cosines, using quotient identities or reciprocal identities. If you see a square, chances are you're going to be using a Pythagorean identity. Again, at the beginning it's trial and error, but once you start to get the hang of it, it'll become a little bit easier. Also use the other side of the equation to give you clues of maybe the direction you need to move into. So we're going to start with, I think the last one I did yesterday was number 11. So let me go through the notes here. And we're going to start with number 12. So again, if you need to have your little reference sheet handy to help you guide you through remembering the Pythagorean identities or the reciprocal identities, have that as a quick reference. Even when we do this when everyone is in person, we would usually give you guys a reference sheet. So as far as that goes, it's the same, but again, all of your tests have been open notes, so no difference here. All right, so let's take a look. You try to always look for the more complicated side. So for this one, my more complicated side will be the left side because I got an addition sign there. So I'm going to go ahead and change my tangent and my cotangent, and I'm going to change it into sines and cosines. So I'm going to use my quotient identity for tangent, and I'm going to change tangent into sine x over cosine x. Switch colors here. So this one I'm going to make it sine x over cosine x. And then the cotangent will be cosine x over sine x. Whenever I have an addition sign or subtraction, I'm going to find a common denominator. My common denominator is going to be both sine x and cosine x. So I'm going to write that in the bottom for both. Not 6x, let's see. Sine x, and then here cosine x, sine x. These are the bottom of the fractions. This one was missing the sine x. Not sine squared, but sine x, sorry. So that's what I had to multiply to get the common denominator. So this new numerator is sine squared x. Over here, this one's missing cosine. When I multiply it to the numerator, it becomes cosine squared x. I'm going to add my numerator. It's going to become sine squared x plus cosine squared x, and then it has the same denominator, which is cosine x sine x. Now, the numerator is actually a Pythagorean identity. So let me go over here and write it down what it is. If you memorize that sine squared x plus cosine squared x equals 1, that's what I'm going to substitute into my numerator. I'm going to change that numerator to a 1. So now I have 1 over cosine x sine x. And now what I can do is split these apart because this turns into secant and this turns into cosecant. So then this will turn into secant x cosecant x, which is what it wanted me to set it equal to. That's way too tight. So it checks. Pretty good. Let's try 13. 13, I'm going to use the same technique. I'm going to change everything to sines and cosines. That was one of the tips. So I'm going to change cotangent into its quotient identity, which is cosine x over sine x. And I'm going to turn secant into its reciprocal, which is 1 over cosine. The cosine x's will cancel diagonally. And now I'm left with 1 over sine x, which is, if I use the reciprocal identity, turns into cosecant, which is what I was trying to make it equal. Pretty good? So for 14, again, I'm going to do the same thing. I'm going to try to make it all into sines and cosines. So I'm going to change cosecant into its reciprocal. So I'm going to change this into 1 over sine x. Now what I'm going to do is subtract these. But in order to subtract these, I have to find a common denominator. My common denominator is going to be sine x. So the first fraction is good to go. It already has a sine x in the denominator. But the second fraction, I need to multiply top and bottom by sine x to get that denominator of a sine x. So the new numerator becomes sine squared x. Now that I have a common denominator, I can add that numerator, and it becomes 1 minus sine squared x over sine x. I'm now going to replace that numerator using a Pythagorean identity. The Pythagorean identity I'm using again is sine squared x plus cosine squared x equals 1. To get it to look like that numerator, I need to move sine squared x to the other side. And now I can substitute. I'm going to replace the top with cosine squared x. So my new numerator is cosine squared x over sine x. Now what I'm going to do is, because this is being multiplied, I could change the numerator and factor it and make it a cosine x times cosine x. And now I can split this apart. I'm going to leave the sine x under the first one. And then just, this is like times 1. And then just leave this one. So now I can turn this into cotangent. This just stays the same. And now I can just flip it around so it looks like what I was trying to get it to. Cosine x, cotangent x. So if you look at this right side, this is what it was equaling. Because remember, multiplication is commutative. So that's why I could flip-flop the places on this. It doesn't matter the order you multiply something. And I'm done. It verified. Let's try 15. Now, 15 is a little different. 15, what I'm going to do is simplify the right side, and I'm going to multiply that right side by its conjugate. So for 15, I have cosine x over 1 minus sine x. This is the right side. This is the side I'm going to simplify. Now, what I'm going to do here is I am going to multiply the top and the bottom, the numerator and the denominator, by its conjugate, which is exactly what's in the denominator, but now it's a plus sign. I need to FOIL the denominator and distribute the top. Actually, I'm going to leave the top. I'm not going to distribute it. I'm just going to leave it apart for right now. So I'm just going to leave cosine x times 1 plus sine x. However, the bottom, the whole purpose behind multiplying by conjugate is to try to get an identity out of this that I can simplify. So I'm going to FOIL the bottom. When you multiply something by its conjugate, all you need to do is first and last. So the denominator becomes 1 minus sine squared x. This is actually an identity that I can use. So what I can do here is, let's see if I have the work here. I do. So the same work that I just did over here, this is what I'm going to replace the denominator with, cosine squared x. So my numerator is going to stay the same. The denominator becomes cosine squared x. Now what I'm going to do is simplify. So I can simplify, take this cosine away, make it a 1, and change this to just the cosine x. So now I have 1 plus sine x over cosine x. Now what we have to do here is think backwards of an addition problem. What I'm looking at right now is the answer to something that was added. So what I can do is undo it, give it back its common denominator, and now it'll simplify to what the other side had. Because this is the reciprocal to secant, and this is tangent. And that's what it wanted me to equal it to, which was up here. So if I bring it down, secant x, tan x. It's simplified. Everybody good on 15? Let's try 16. So for 16, I recognize at the top that I've got potentially a Pythagorean identity that I can use. So the Pythagorean identity I'm going to use for the numerator is 1 plus cotangent squared x equals cosecant squared x. I'm going to move the 1. So cotangent squared x equals cosecant squared x minus 1. That's what I'm going to substitute. So the new numerator becomes cosecant squared x minus 1 over 1 plus cosecant x. Now, back in 7.1, we learned how to factor the difference of two squares. That's what's in the numerator. So I'm going to factor that. It factors into cosecant x plus 1, cosecant x minus 1. You will have to factor on the quiz on Friday. Once I factor this, I can now simplify, and these will cancel. Now, notice it's not the same order, but remember, addition is commutative. And what I mean by that is that if I add 2 plus 3 or 3 plus 2, either way I get 5. So the same thing here. Cosecant x plus 1 is the same thing as 1 plus cosecant x. These are the same thing. So these cancel out, and now I'm left with cosecant x minus 1. Now remember, I'm trying to make it look like this. So if they were expecting you to simplify both sides and get rid of fractions, then I would go and try to simplify the right side. But I'm not going to go there. I'm just going to keep making it look like the right side. So what I'm going to do is turn this cosecant into its reciprocal, which is going to be 1 over sine So change this to 1 over sine x minus 1. Now I need to find a common denominator. So I'm going to change the whole number 1, and I'm going to multiply it by sine x over sine x, because that's my common denominator. So now I have 1 over sine x minus sine x over sine x. And then if I add the numerator, I end up with 1 minus sine x over sine x, which is what I was expected to make it simplify to. And you're done. We're going to do the same thing on the next one, but instead it's going to have secant in it. Pretty good there. All right, let's try number 17. Again, the numerator is a Pythagorean identity. The Pythagorean identity I'm using is tangent, maybe write it up here in the white area, tangent squared x plus 1 equals secant squared x. So I'm going to take out, move this over first. So tangent squared x equals secant squared x minus 1. That's what I'm substituting. So secant squared x minus 1 over 1 plus secant x. I can factor to difference of two squares. So this becomes secant x minus 1, secant x plus 1. I can simplify. This cancels. And now I'm left with secant x minus 1. Again, I'm trying to make it look like that right side. So again, let me put it into its reciprocal. Let me come over here so I have more room. So I'm down at this point now. My goal is to get it to this, 1 minus cosine x over cosine x. So I'm going to change this to its reciprocal, 1 over cosine x minus 1. Now I need to find a common denominator. It's going to be cosine. I can add the numerator. And now it looks like this side. 1 minus cosine x equals, or over cosine x. It's done. Next one, it's sort of like what we did in 7.1. I'm going to factor out a greatest common factor. Pretty good on 17. Let's go to 18. So I'm going to simplify the right side. I'm going to factor out a greatest common factor of tangent squared x. So that's my GCF. So I'm dividing both sides by that GCF. What remains here is secant squared x minus 1. This is a Pythagorean identity, what's in the parentheses. Let me see if I can find where I just simplified that. So right up here is where I simplified it. So I'm going to replace secant squared x minus 1 with tangent squared x. So now I have tangent squared x times tangent squared x. When I multiply this, I add those exponents, and that's what it wanted me to equal it to. And I'm done. Now the next one's a little different. We're going to do a substitution of an identity. but we're going to factor the cosecant to the 4th power. So for number 19, I'm going to, and this one, it's really helpful if you look to see where you're going. So what I'm going to do is I'm going to factor this. I'm going to change this into cosecant, and that's not showing up very well. Cosecant squared x times cosecant squared x. I still have the cotangent. Now, what I'm going to do now is a substitution. I'm going to use the Pythagorean identity. I'm going to take out this cosecant and I'm going to replace it with its Pythagorean identity. So let me go down here and I'll show you which one that is. So the one I'm going to replace it with is 1 plus cotangent squared x is equal to cosecant squared x. So this is what I'm going to substitute in here for this cosecant. So I'm going to take out the cosecant and put 1 plus cotangent squared x. Now I still have this one, and I still have this one. Now if you look at what you're trying to get it to, notice over here I've got a cosecant squared x, and that's what I have here. So now all I need to do is to get the parentheses to look the same, distribute this cotangent x in here. So the cosecant squared x stays, distribute the cotangent, and now it looks the same. Bring that down. Equals cosecant squared x times cotangent x plus cotangent cubed x. And it checks. So that was a little different. It was all being multiplied where we substituted. But again, you can take anything out and substitute it. And that is it for the notes on 7.2. Now what we're going to do is I'm going to go over last night's homework. Yes?
Can you go back to 18?
Yes.